A lightweight point defense fighter with stealth and kinematic performance to match the F-22 lurks in the desert mountains of Iran. Wait, really? Apparently, or so the Islamic Republic of Iran would have you believe. In 2013, it revealed what it calls the F-313, manufactured by the Iranian Aircraft Manufacturing Company. The intent is to have a combat-capable aircraft for point defense that can contend with Western aircraft. For this reason, it is designed to be small, nimble, and stealthy. Looking at the design, we can see it as a faceted aircraft instead of smooth. The reason for the F-117 having such a design was because of the limitation of computing power to calculate the radar cross-section. 3D modelers will know that to recreate a smooth rounded object requires many polygons. The high poly count means that the amount of calculations per any viewing angle increases drastically. To cut down on the required computing power, they simply resorted to using flat surfaces. However, this comes at the cost of producing an aircraft that is aerodynamically inefficient, as the sharp corners lead to disturbances in the air instead of achieving a smooth laminar flow. The faceted surfaces on the F-313 suggest similar computing restraints. The intakes are mounted on top of the aircraft. This means the intakes are hidden from ground-based radars quite well, but if they were to go to war with the West, ground-based radars aren't too much of a concern. Carriers will likely be too far to track effectively, especially with the shadows casted by the mountainous terrain. Western militaries also tend to place greater emphasis on networking aircraft that take on a bigger share of the burden than Eastern countries like Russia or China. The main exception would be Saudi Arabia, but that would imply Iran would be on the offensive, which defeats the point of a defensive fighter, not to mention Iran's power projection in the traditional sense is extremely limited. So ideally you would primarily worry about aerial threats given the stated mission statement of this aircraft. Even then, this placement makes no sense, as having the intakes on top mean there is nowhere to curve them within the body of the aircraft in a way that allows for a weapon bay. That lack of a curve means you can use a radar platform to peer into the aircraft and see the extremely reflective fans in the engine. Having them on top also introduces problems during high angles of attack, as the fuselage of the aircraft would prevent the engines from being fed enough air. The two engines are the General Electric J85 turbojet engines. These are very dated in terms of design and materials. Newer engines utilize digital controls to interpret pilot commands and manage the engine sufficiently to enable the intent behind those commands. Newer engines are also leaning towards wider blades, with more exotic materials so they can run hotter without deforming, allowing for tighter tolerances and more efficiency. Even then, of course, there is the obvious, no turbofan. A low bypass ratio engine as the added airstream has multiple benefits, including cooling and increasing the amount of moved mass. The major benefit is giving something for the core exhaust to expand into, as the pressure is increased compared to the normal atmosphere. The airstream itself also expands into the atmosphere as well, giving additional thrust. The drawback is increased drag at supersonic speeds, as all that additional air has to be slowed down for the engine to function. This is why military aircraft prefer low bypass ratios compared to civilian aircraft that prefer high bypass ratios. With two J85 turbojets, they will lack efficiency, limiting their range. Having two engines instead of one in such a small aircraft is also detrimental, as that further increases the fuel burn. Jet engines' efficiency peaks at a certain throttle setting, but having two engines means you'll never achieve that setting. This means that the fuel consumption is more than doubled in any flight regime. Probably the most striking feature is the wings. It uses a canard delta configuration, which on paper is a good choice. The canards are great for manipulating the center of lift and can enable very high angles of attack without stalling. The canards are also aligned with the main wing on the z-axis, so they wouldn't be that detrimental to stealth either, unlike the J20 which are misaligned. The main wingtips are canted downwards, which suggest a couple things. At first glance, it would appear they're optimizing for supersonic cruise, as the downward wingtips would allow them to achieve greater lift by redirecting energy from the shockwave from the fuselage. This is quite impressive until you see the aircraft head on and realize what is truly happening. The wingtips are positioned in such a way to offer increased yaw stability, with the angle of incidence suggesting they are also wanting to inherit trim to balance out the center of lift. Aircraft stability in regards to pitch is determined by positioning the center of lift in relation to the center of gravity. With the center of lift being behind the center of gravity, the plane is stable, meaning in relatively uniform air it will correct itself and achieve equilibrium over time. The drawback is the amount of drag that is produced, as the stability is achieved by balancing weight in the nose with downward trim in the tail. With the center of lift in front of the center of gravity, the aircraft becomes unstable. This means without intervention, the aircraft wants to pitch up. The amount of upward force increases exponentially with time. The aircraft will remain in equilibrium for a split second, but with each additional split second that passes, the nose up tendency increases, something along the lines of a factor of 10 for every tenth of a second, depending on the level of instability. This means that if a computer is used to trim the aircraft, as long as it is fast enough, you can keep the aircraft stable with very minimal drag. And the trim would be positive, as in producing lift, instead of negative, or reducing lift. This lowers fuel consumption drastically, and makes the aircraft extremely agile. The reason canards are great for this compared to a traditional tailplane, barring other aerodynamic features, is that they can induce instability by producing lift, whereas a tailplane induces instability by decreasing lift. So the canard delta choice is actually a wise move in theory, but the aircraft is designed to be stable, as evident by the rear wing. The engines are the heaviest component of the aircraft, which shifts the center of gravity towards the rear. The canards shift the center of lift forward. Without fly-by-wire, the aircraft would be unflyable. Part of this is mitigated by the placement of the fuel, but that works only until you run out of it. The angle of incidence means they're likely trying to shift the center of lift back towards the rear, where the center of gravity is. This is similar to the F-4 Phantom that had a lifting body but downward-facing engines. This is likely to counter the stability issues such a fuselage would encounter at slow speeds, especially at landing. Even then, the aircraft was notorious for having stability issues during this regime of flight. This is also seen on Boeing's Bird of Prey. It was intended to be stable to avoid requiring fly-by-wire, keeping costs low as a privately funded venture. The problem is this design is limited by airspeed. The faster you go, the more center of lift shifts towards the rear. Even aircraft like the F-16 or F-22 are stable at supersonic speeds. The trim afforded by the angle of incidence also means the nose-down tendency at higher speeds means the aircraft would be unflyable. With the Bird of Prey, it was limited to less than 200 knots indicated. The F-313 shares almost the exact same speed limitations, as indicated by the speed indicator in the cockpit. Speaking of the cockpit, not really much to say here. The avionics are low-cost civilian avionics, typically found on general aviation aircraft. Obviously, this is not an avionics suite that would enable any combat effectiveness at all, as there are no sensors for detecting enemy forces, let alone controls for the weapons. With all that said, the F-313 is likely just a propaganda talking piece. The Islamic Republic of Islam is known for mismanaging the country's economy, leading to significant brain drain over the last couple decades. The military too is in a horrible spot, operating small numbers on many airframes. If you've seen my Air Force composition video, you already know why this is bad. Currently, the ruling regime is facing domestic unrest on a massive scale. Only time will tell if meaningful change is achieved. The tension leading to this situation has been present for ages, however, so this aircraft likely would have been useful for attempting to restore some sort of confidence in the ruling regime domestically. Or at least, that would have been the hope. Thank you for watching. We aim to take complex aviation topics and make them more digestible. If you enjoy this content, then please subscribe. In the meantime, enjoy your dance with the angels.